Hi calculus students, we're here going to do the same function, but this time we're going to be measuring using 8 rectangles, and on the left sides of the interval we're not going to actually draw the picture this time. We're simply going to think about the breakdown. So we're going to start off with 0, and then since we're starting on the left side, we'll start at 0, and then we want to think about what's the increment. Well, my width is still 4, but now we're dealing with 8, so we're going to have a half increment. So we're going to start off here at 0, then go to a half. These are all the values we're going to use, right? And then at a 1, and then 3 halves, and then 2, and then 5 halves, and then 3, and then 7 halves. So we have the 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8, and all those numbers are going to be the values of x that we're going to find the height, which is still going to be the square root. So since we do have a common width, the common width would be a half here. We're simply going to say that this can be calculated by saying 1/2, and square root of 0 is obviously 0, and then we're going to add to that a square root of a half, and plus the square root of 1, plus the square root of 3 halves, plus the square root of 2, plus the square root of 5 halves, plus the square root of 3, plus the square root of 7 halves. And that's all we have to do to find the left-hand approximation. And then we get multiply that all by a half. Don't forget that the half is the common width. That we're going to be with an approximation, I believe, of 4.7. Let's see here, 4.765. Okay. One thing to note that since we are using left endpoints, I said I wasn't going to graph it, but I'm going to do a quick sketch. We're doing left endpoints, and the graph here is always increasing. Then using left endpoints will be an underestimate. And our first example was an overestimate because we were using the right endpoints and the function was increasing.